Hello everyone. So far we have seen how to look for a dataset, download it, and then open it using a tool. So today we are going to have a closer look at the dataset and try and understand the same. So when we open it using Excel or Google Sheets or any other tool, this is how the data would look like. And if you recollect, the columns of these particular dataset are referred to as features, and in the rows are called as data points. So what are these particular features in this dataset? So here, the player stands for the name of the player. The team indicates the team that he has represented. Match accounts for the number of count of matches where the player has participated in. And in all the matches, a player might not get to bat. So innings counts the number of matches where the player has gone out to bat. So this value can be equal to or lesser than the count of matches. Not out stands for the number of matches where the player has finished an innings without getting out. Runs stands for the total amount of runs that the player has scored in all the innings that he has played. HS stands for high score, which indicates the highest amount of runs a player has got in a particular innings. Then comes average. So average can roughly be translated to what is the expected amount of runs a player will score in an innings before he gets out. So the way we calculate it is we take the total amount of runs the player has scored and divide it by those innings where he has gotten out. So for this particular entry, the runs he has scored is 162 and he has batted in 6 innings and has been not out in 2 of them. So we take 6 minus 2 and we get 4 and we divide this 162 by 4, giving us an average of 40.5. So in general, higher the average, the better. We can say that if a player has a higher average, he might be a better player. Likewise, we look at strike rate, which is how quickly the player is able to get runs. In the case of strike rate as well, having a higher strike rate is better. Then we have features which counts the number of hundreds, the number of 50s, and how many times the player has gotten out on 0. We would prefer this value to be as low as possible. So in our data set, we have had 12 features. We just had a look at what they were. And the actual data set contains 247 points. So in this image, we have only shown the first 9. Now let us see if we can work with fewer features. We wanted to look for a very good opening batsman. Let us say if we were to specify it further, we would want a batsman to score runs quickly and another is to score runs consistently. So from the 12 features that we had, these requirements are captured by these two features. One is strike rate, which is how quickly the player scores runs, and the other is average, which is how many runs is he expected to score in an innings before he gets out. And we just saw it can be also calculated using the other features present in image files as such. Another example could be that you have details of height and weight of a person is called as, and we might want to introduce a new feature, say body mass index. Okay. And we know that we can calculate BMI using the features. So here we have listed a few sources and let us actually. So if the feature is not given to you, this is how we would have calculated it. Okay. Now let us also have a quick first one is called what strike rate and average is, maybe how to calculate it so that we are clear about it. Now here we have taken an example of a player A scoring 10 runs in 4 balls. So we get the value, when we divide it, we get the value 2.5 and then we multiply it with 100 to say that he had a strike rate of 250%. Likewise, player B has scored 20 runs in 20 balls and when we divide the value we get 1. We multiply by 100 and say that his strike rate is 100%. Now even though player B has scored 20 runs, his strike rate is lesser than that of player A. And we said strike rate is about how quickly the player can get runs, and so higher the strike rate, the better. So in this particular example, player A's strike rate is more desirable. When we come to average we said is we take the runs that the player has scored in all his innings and divide it by those innings where he was not out. So in the first case, we have the player scoring 300 runs in 10 innings, but he is out in all of them. So his average can be calculated as 300 by 10, which gives us 30. Then we take player B who has scored 450 runs in 10 innings and is also not out in one match. So his average is calculated as 450 by 10 minus 1, which is 9. So giving us a value of 50. So once again, higher the average, the better. So in this example, player B's average is more desirable. So now that we have decided on what features we wanted to have a look at, let us also have a look at a smaller number of data points. So we had 247 players, but not all of them are opening batsmen. And it is also hard for us humans to go through all those 247 values and compare them. So for this exercise, we have only taken 8 players and we are going to see if we can answer the question on the basis of these 8 players. So we said higher the average, the better, as well as higher the strike rate. So if we look at the top two averages, we have 42.8 by JC Butler and 37.6 by PD Salt. Likewise, if we have a look at the strike rate, the highest is 159.32 by PD Salt and 158.51 by JC Butler. So we see that both average and strike rate, the top two contenders have been JC Butler and PD Salt. So perhaps those two are good contenders to be a very good opening batsman. So subsequently, we are going to make use of tools and see how we can deal with a large number of data points. Thank you.